So students, in this session, we will try to understand that what are the packages which are available. We will be discussing SQ prop package in depth and try to understand. Apart from that, we will also understand the concept of multiple axis and how we can create network graphs. So students, the first thing we have to understand in this session is how to draw a plot with two y-axis in R. F create a sample data such that the sample data consists of three numeric vectors x, y1 and y2. The x data will determine x-axis information, whereas y1 and y2 will be used for two y-axis simultaneously. Create a scatter plot with two different colors and y-axis values on the left and right side of the plot. So basically the idea is when we are creating with two different colors. To do so, firstly, we will create white space around the plot. This leaves space for second y-axis. This can be done using the par method. Now, create the first plot, that is the red cross dots around the first y-axis that takes into account data y1. Plot x, y1, pch, col. So this is the basic syntax. Next, set to true in par method. This needs to be called again after the first plot has been created. This tells the plot that the new plot will be drawn over the first one. So basically par method is used to recreate another axis. You can see par is equal to new equals to true. So new equals to true. Next, plot the second plot now with taking y2 data in account. Plot x, y2, pch 15, col equals to 3, axis equals to false, x label is equal to dash and y label equals to dash. So this is the syntax. Next, set axis or any additional attribute if required. Now we have the code. Let's understand this code. Create sample data set.seed 2585 x is equal to r norm 45 and y1 is equal to x plus r norm 45. I hope you understand r norm is the normal distribution. You can see over here that we have stored the value of x plus r norm 45 in y1 variable and x plus r norm 45, 7 in y2 variable. First, draw plot using axis y1. Mar equals to c 7354 plus 0.3. Plot x, y1, pch is equal to 13, col equals to 2. So you can see over here that the plot function is used. Now, set parameter new equals to true for a new axis. So how we are doing it? We are doing par new equals to true. So we are setting a new axis. Draw second plot using axis y2 and here you can see plot x, y2 where pch is equal to 15, col equals to 3, axis is equal to false, x lab is dash, y lab is dash. So you can see over here we are calling the axis function, side equals to 4, at equals to pretty. Within pretty, we pass the range function and within range, we pass the axis which is y2 axis. Now, mtext is equal to y2, side equals to 4 and line equals to 3. So you can see we have called the axis function and the mtext function. Now, this is the required graph that we are getting on the screen. You can see over here that here is the graph where two axes are there. You can see x-axis is there and y1 and y2, two axes are there. So let's have a look of this visual cue and understand. You can see that on one y-axis, which is y1, the scale is ranging from -2 to +2. On the contrary, for the variable y2, or we can say the axis y2, the scale is ranging from 3 to 10. So students, that was about a scatter plot that we created with the help of the plot, and we created two colors and the data points were of two colors. Now, let's have a look of one more type of graph where we are plotting the line graph. You can see over here again in this example, there is x-axis, there is y1 axis and y2 axis, and accordingly there are values. So for the x-axis, the values are from 2 to 10 and from y-axis it is 2 to 8, or you can say the values are random numbers are there. Likewise y2, the random numbers are there. So draw first plot using axis y1. You can see par and mar equals to c 7354 plus 0.3. Then we have plot where x comma y1, which is the set of x and y1, type is equal to I and call equals to 2. So you can see over here set parameter new equals to true for a new axis and par new equals to true. So again I have created a new axis. I'm drawing the second plot using the axis y2. Again I'm calling the plot function where I see x, y2, type equals to I, call equals to 3, axis equals to false, and xlab is equal to ylab. Axis is side equals to 4, at equals to pretty range y2, and mtext is equal to y2 side 4 line equals to 3. So you can see over here that I have plotted the graph once again, and with the help of this I'm trying to plot two graphs at the same time. So students, that was about multiple axes, and now let's have a look on the contour plots in R. So how can I create a contour plots in R? So how to make a contour plot in R? We have to load plot ly in the library. Now plot ly is what? It is a package which I am loading using the library function. Now in the plot ly, I use the plot ly function, and within the function I pass z equals to tilde volcano, type equals to contour. So you can see over here that the type has been equated to contour, so it will give you the contour plots. And the entire thing has been stored in a variable fig. So fig is my variable. Now you can see over here that if I want to set the x and y coordinates, what will I do? I have in the first line I have loaded the plot ly with the help of library. I repeat, plot ly is my package. In that I'm calling the plot ly function, and in the plot ly function I'm passing certain parameters. So let's have a look what these parameters are. X is what? X is my range of values on the x-axis, y is my range of values in the y-axis, and z is my matrix where again I am having values in the form of rows and columns. So there are 5 rows and 5 columns. Type equals to contour, and then I'm trying to print the fig. So I'm trying to give my result. So you can see over here that I have passed first is x vector, second is y vector, and third is z matrix. Then we can see set size and range of a contour. Library plot ly is equal to type equals to contour, z is equal to matrix, and color scale is equal to jet. Auto contour is f, and contours list is equal to start 0, end 8, and size 2, which means that I have start and end value which is from 0 to 8 and size is equal to 2. So basically I am trying to give the properties of the contour. I am saying auto contour, it is equal to f. Color scale is equal to jet. So these are all attributes. Color scale, auto contour, contours, these are all attributes which are equated to a particular value. And the entire plotted contour is stored in the variable fig. So that is how I'm setting the size and range of a contour. So students, I hope with this code you are able to understand that how to set size and range of a contour. Next, we will understand what are network graphs. Network, we all know that sometimes we need to understand the data in terms of nodes and how they are connected to each other. How the nodes are pointing to each other, which node is connected to which node, what are the connecting lines, and such kind of network graphs are very useful. Network graphs are an important tool for network analysis. They illustrate points referred to as node with connecting lines referred to as edges. So basically, network graphs are having points which are called as nodes, and they have connecting lines which are called as edges. So you can consider that the points are nodes and the connecting lines are edges. Since network graphs are such useful tools, there are many options for graph generation. Let's have a look on how to build network diagram with R. So students, there is iGraph package. The iGraph package is the most important R package when it comes to build a network diagram with R. It basically allows to build any type of network with R. Let's have a look of network graph in R with plot ly package. So students, we are using the well-known social network of Esquisse Karate Club. GML format file can be collected from here. Library function is loading plot ly package. Library function is also loading iGraph package, and library function is also loading iGraph data package. Now in this data function I'm passing karate, and package equals to iGraph data. G equals to upgrade graph within brackets karate, and L equals to layout.circle and within brackets G. So what we are doing over here, we have created a data. We are passing the karate and we are upgrading the graph and storing that in G. And there's a layout circle. We are passing G variable into that, and the layout circle is stored in L. Now we have to create vertices and edges. Now you all know what is a vertex. Vertex is a data point and edges are the connecting lines. So here we have V and within brackets we are passing the G. So you can see over here that G is our upgrade graph, and now we are creating a vertex and passing G as a parameter and storing that in VS. Now ES is equal to as data frame and within brackets get.edgelist and within brackets G. Length VS. Now length VS means that I am trying to find out the length of the VS. VS variable is what? That is creating the vertices. So length of the VS will be stored in NV variable. Likewise, length ES at the first location, I am trying to find out the V1, that is the first vertex. So that is stored in the NE variable. So that is how I am using the length function to find out the length. I am creating the nodes. So I call plotly, I load plotly package with the help of library function. And then in the L, I pass comma 1, which means L is what? L is my variable where I am having the layout of the circle. If you can recall that layout of the circle was passing G, and now this layout of the circle is having comma 1 and comma 2. So that is how I am storing in the xn the first, and in the xy yn the second value. And now I am calling the plotly function once again, and I am storing x equals to tilde xn and y equals to tilde yn. Mode is markers, text is equal to vs $label, hover info is equal to text, and that thing is stored in the network. You can see over here edge shapes equals to list. So you can see over here that we have used the for function. In the for function, I am calling I in 1 till ne, which means the length of the node from 1 to length of the node, and that has started traversing the entire network. So here we are storing in V0 and V1 the vectors. Edge shape is equal to list, where type is line, line is having some color and width, and x0, y0, x1, y1 are my values of the vertex. And finally, edge shape is equal to edge shape. So that is how this is a little logic where I am trying to create a edge, and I have created the edge. Now, creating a network. How I create a network? I call the list function along with the title, show grid equals to false, show tick labels is equal to false, zero line is equal to false. So these all are the properties. I call the layout function. In the layout, I write network, title equals to karate network, shape equals to edge shapes, x-axis is equal to axis, y-axis is equal to axis. I'm storing everything in fig. Let's talk about plotly function in detail and understand what plotly is. So students, plotly is an R package for creating interactive web-based graphs via the open source JavaScript graphing library, plotly.js. So you can see plotly.js is there, and that is the graphics library. As of version 2, November 17, 2015, graphs created with the Plotly R package are rendered locally through the HTML widgets framework. Use the install.package function to install the Plotly R package from CRAN library. So you can see over here that I'm using the install.package function and I am installing the Plotly package. And that is how I have started using this package.